Unit 10, Day 3 notes. Today we're going to talk about inscribed angles. An inscribed angle is an angle formed by two chords where the vertex is on the circle. So on my picture on the right, it appears that angle R is an inscribed angle because angle R, the vertex R, is on the circle's edge. So again, angle R is an inscribed angle. Intercepted arc. An arc whose endpoints lie on the sides of an inscribed angle. So using the same picture, arc QS is an intercepted arc. Inscribed polygon. We mentioned this on day 1, but again, an inscribed polygon is a polygon that is inscribed in a circle where all of its vertices lie on a circle. So just refer back to day 1's notes and you can redraw the same figure or create a new one, doesn't matter. But for example, let's say I have these 3 points on the circle and I connect those 3 points, it would obviously form a triangle. So this triangle is inscribed in this circle because all of its vertices, vertice is another word for corner, so all of its corners are on the circle. Theorem 10.6 says, if an angle is inscribed in a circle, then the measure of the angle equals 1/2 the measure of its intercepted arc. So we're using our same circle from above. We've already established that angle R is an inscribed angle. So what theorem 10.6 is saying is that the measure of angle R is going to equal 1/2 the measure of the arc that it intercepts, and it intercepts arc QS. So the measure of angle R is equal to 1/2 the measure of arc QS. Another way of looking at it is the measure of arc QS is equal to twice as much as the measure of angle R. So it can be looked at in forwards and reverse, even though you don't see the words if and only if, but that's 2 ways of looking at it. Now, on day 1, when we first introduced arcs and central angles and things, we were told that the central angle and the arc that is formed by the central angle will have the same measure. And that's still a true fact. So on this angle here, angle EGF, if I want to look for its measurement, it's going to be the same as the arc. That arc we're referring to is arc EF. So the measure of angle EGF is also 84 degrees. So again, the measure of central angle will equal the measure of the arc. Now, when it's in an inscribed angle, and I'm looking for the angle, we just mentioned it in theorem 10.6 that the measure of the angle is equal to 1/2 the measure of the arc. So the arc we're talking about is still EF. So I need 1/2 of 84. And half of 84 is 42. So the measure of EHF is 42 degrees. So make sure you understand the difference between an arc formed by a central angle. Central angle uses the center of the circle. if that helps. Inscribed angles do not use the center of the circle. There are points on the circle. So having this side-by-side picture should help you establish the difference between the two types of angles so that you can correctly find the difference to the different arc measures or the different angle measures. Theorem 10.7 says if two inscribed angles of a circle intercept the same arc or congruent arcs, then the angles are congruent. So on my picture at the right, I'm showing that angle C is intercepting arc DA, and angle B is also intercepting arc DA. So since those two angles, C and angle B, intercept arc AD or DA, then angle C is congruent to angle B, according to theorem 10.7. On 10.8, it says an inscribed angle of a circle intercepts a diameter or semicircle if and only if the angle is a right angle. So on my picture here, the inscribed angle we're referring to is angle G. Angle G intercepts the diameter or semicircle. So it's intercepting arc FJH, which is a semicircle, then angle G, or the measure of angle G, equals 90. That's what this theorem is saying. Since angle G is intercepting a semicircle, then the measure of angle G is 90 degrees. It could also be looked at in reverse. I know my handwriting is terrible, so forgive me, but that's why we need to listen clearly and write as I speak. In reverse, it would say if the measure of angle G is equal to 90 degrees, then angle G intercepts semicircle FGH. But even so, that should make sense because you could go back to theorem 10.6 and show that you already know that FGH is a semicircle, so it measures 180 degrees, right? And we said that the angle G would be in that case, will be half the measure of the arc. So if the arc is 180, then half of 180 is 90. So it's basically tying 10.6 to, or proving that 10.6 is correct. All right, on 10.9 it says, if a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. Quadrilateral, again, means four-sided. So opposite angles are going to be supplementary. So in my picture here on the right, the opposite angles it's referring to would be angle L with angle N. So the measure of angle L with the measure of angle N will equal 180 degrees. And the other set of opposite angles, K and M, will also be supplementary. So angle K together with angle M will also be equal to 180 degrees. So let's practice some examples with each one of these theorems so that they become a little more clear. So for number 1 here, it wants us to find each measure. The first measure it wants us to find is the measure of angle P. Angle P is intercepting arc MN. So the measure of angle P is going to be half of arc MN. So that means it'll be half of 70 degrees. And half of 70 degrees is 35 degrees. So the measure of angle P is 35 degrees. Now it wants us to find the measure of arc PO. Here's arc PO, and it's being intercepted by angle N. So arc PO will be twice the size of angle N. So that means it'll be 2 times 56, which would end up being 108, I believe. Yeah. I'm sorry. 112. 112. Because 55 is 110. And 2 more. $112. And if you didn't notice, we were using theorem 10.6. On number 2, we have angle T intercepting arc SV, and angle U also intercepting arc SV. So that means angle T is congruent to angle U. So that means their measurements are equal. So the measure of angle T is equal to the measure of angle U. So since that is the case, we are using 10.7, and we'll use 10.7 to find x, which would then help us find the measure of angle T. So we're going to take 3x minus 5 and equal it to 2x plus 15. Subtract 2x on both sides, which would leave you with x minus 5 equals 15. Add 5 to both sides, and you get x is equal to 20. So again, I'm not done because it didn't ask us to find x. It wants us to find the measure of angle T. So now I'm going to use x to substitute. So it would be 3 times 20 minus 5. 3 times 20 is 60. 60 minus 5 is 55. So the measure of angle T is 55 degrees. All right. For number 3, it wants us to find the measure of angle F. And we see a triangle in the picture, so most likely it has something to do with theorem 10.8. And theorem 10.8 said that if you have an arc intercepting a semicircle, an angle intercepting a semicircle, and that angle in the picture would be angle G. Angle G is intercepting arc FH. So that means that angle G is a 90-degree angle. And since there is a triangle and it's showing, and we know all 3 angles, we know all angles of a triangle will add up to be 180 degrees. So again, that means angle F plus angle H plus angle G is equal to 180. So F is 4x plus 2, H is 9x minus 3, and then G is 90, according to theorem 10.8. So now let's start combining like terms so we can isolate x. 4x and 9x would give us 13x. 2 minus 3 is negative 1. Negative 1 plus 90 is positive 89. Then we have to subtract 89 from both sides, which would leave us with 13x is equal to 91. And divide both sides by 13. And x is equal to, I believe, it's going to be 7. I'm pretty sure it's 7. But again, I'm not finished because it doesn't want us to find x. It wants us to find the measure of angle F. So F was equal to 4 times x, so 4 times 7 plus 2. 4 times 7 is 28, and 28 plus 2 is 30. So the measure of angle F is 30 degrees. And last but not least, number 4 has to deal with problems related to theorem 10(9), which stated that if a quadrilateral is inscribed in a circle, the opposite angles are going to be supplementary. So that means A together with C are going to be supplementary. So angle A plus angle C is equal to 180. So angle A plus 90 is equal to 180. Well, that means the measure of angle A would have to be 90 degrees. That one wasn't so bad. Now we have to find the measure of angle B in the same manner. Angle B plus angle D is equal to 180. Angle B is 2x minus 30. Angle D is x, and they're equal to 180. Combine like terms. So 2x plus x would give you 3x minus 30 equals 180. Add 30 to both sides. You would have 3x is equal to 210. Divide by 3 on both sides, and you would get x is equal to 70. But we're not looking for x, we're looking for b. So I need to substitute x in to find b. So it would be 2 times 70 minus 30, which is b. So 2 times 70 is 140. 140 minus 30 is 110. So B is equal to 110 degrees. And this concludes your notes for today.